This Smith spreader is a ground-driven rear-wheel drive spreader like most horse-drawn spreaders are. When I was still back working with horses, I had a new idea spreader that had steel wheels and a metal beater bar, and more typically along the line of horse-drawn spreaders. And that's what caught my attention about this spreader, was how different it was. Many of you are sending me pictures of different style spreaders, and I realize there's lots of different styles. And one of the sales pitches that I've been reading about on these Smith spreaders is how simple they operated, and therefore they were more reliable. There's no gearboxes, no worm gears, that type of deal. It is a simple drive gear. So this is the engagement wheel that runs the sprocket here, that runs the rear beater that we were just fixing on this back bar. So this wants to come off fairly easily, and this spins free, but in order to get it off, I need to get this drive gear off of the rear axle here. There's a cotter pin on the back side of that one. Yeah, this cotter pin is missing. There we go. Haven't been inside of one of these before, but it has two big heavy set screws here. Many of you ask why I don't use square sockets. Well, this is one of those places where square socket might really be handy. This one's a little more inconvenient because this wheel is in the way. If I can get in on that. Now this is kept in by a little keeper back here, by that bolt right there. Not sure if you can see it, but this little keeper right here this was the keeper right there. That sled on that shoulder right there to keep that in place. So the small set screw kept the key in place that locked the wheel to the axle. So this axle is supposed to turn inside this housing. And the small set screw kept that one in, and this large set screw actually locked right down into the axle itself. And there's an oil hole here with this cover. That was to oil this axle into this housing. And it has all appearances that it is frozen in that housing as well. This back shaft that the big sprocket ran on doesn't look like it was meant to rotate. It has a locking set screw here, so this shaft wasn't meant to rotate, but still it should be able to come out. So in last week's video, probably the most common suggestion that I use as a penetrating fluid is candle wax, paraffin, and some mentioned beeswax. I've used beeswax for years and years as a cutting fluid because the wax tends to be drawn to the heat, whereas a petroleum-based fluid tends to be expelled by the heat, in my experience. It was an old tool and die maker that told me that years and years ago. So I understand it's kind of like soldering. The solder is drawn to the heat. This wax is drawn to the heat. Question is, on this last sprocket that was the toughest one on the left side, also was the toughest one on the right side, was it the wax that made the difference, or was it the heat that made the difference? I speculate it was probably the heat was the biggest factor to burn that rust out. Drawing that wax in may have been a nicer lubricant when taking it off. Yeah, I don't know. Did it actually work to break down the rust? I don't know either. I think heat probably did it. Anyway, it was kind of fun to test all your suggestions, and I do appreciate all your input. There were some other suggestions too that maybe I could test those too. Anyway, appreciate you coming along. Thanks for watching.